It was just like, it said point 3, -4 lies in the curve y equals 4 over 2 minus x. And then it said if q is the point x comma 4 over 2 minus x, use your calculator to find the slope of the secant line.
Excellent example. I was going to start with that. So let me, yes.
I don't have the printed. Is it okay if I? That's what I'm
Of
looking at.
course, you don't have to
Okay,
print.
'cause
You don't have to print
I
it out.
remember you mentioning that if you catch us on our phone, I'm
Yes,
looking at the problem.
yes, of course, absolutely, yes. Okay, so this is section 2.1, and let's just discuss a little bit about tangents, velocities, before we address this particular problem. Okay, here is a scenario. I'm looking at a function. The function is this. I will select a point, and I'm going to call that point P. And I will select another point. I'm going to call that point Q. I'm going to draw what is called the secant line, the line that crosses the graph of a function in 2 points. So this is secant line PQ. I'm going to, of course, put some x values here for these 2 points. I'm going to call this A, and I'm going to ask you to tell me what is the y-coordinate of point P. Excellent. I'm going to put here x, and I'm going to ask you to give me the y-coordinate of Q. Perfect. And of course, then I'm going to ask you to give me the slope of the secant line PQ.
Slope f of x minus f of a over x minus x.
Do we all agree with this? Excellent. Is that okay? Perfect. Now, here's what I would like to do. I would like to move this point Q here. And I would like to determine the slope of this line. And then I will move Q here. And then I will determine the slope of this line. And then I will move Q here. And then I will determine the slope of this line. And as Q approaches P, not equal, not identical, what happens to the slope of the secant line PQ? Will approach. What do you think? So initially I had this. Maybe this is too. All right, let me try something thinner. So initially I had this, and then I have this, then I have this, and as Q gets closer and closer to P, I have this. So initially it was this, then this, then this, then this, then this. So this, as Q gets closer and closer to P, the slope of the secant line gets closer and closer to the slope of the tangent line at
A or
at
P.
right. Okay, one more time. So this is the first situation. This is the second situation. Here's the third situation. And then closer and closer, and this will be the last one that I'm interested in. What will that be?
P's.
Exactly. The slope of the tangent at P. Do you agree with this concept?
Okay.
Does it make sense?
Yeah.
So If I ask you now in this scenario, find the slope of the tangent line at P, what will you say? I can't. I only have 1 point. I don't know how to determine a slope of a line if you only give me 1 point. I don't have a formula for that. I only have y2 minus y1 over x2 minus x1. If you don't give me 2 points, I won't be able to find the slope of a line. So I'm not giving you 2 points. I'm giving you 2 points on the graph. I'm not giving you 2 points so you can determine the tangent at P, but I'm giving you 2 points on the graph, and then I say, okay, if Q is here, we get a different slope. If Q is here, we have a different slope. But if Q is very, very close to P, I could say that that will become the tangent at P. Basically, I'm not using the equal symbol. I'm using approaches the slope, which means the slope of this line is not equal to the slope of this line. It only means that the slope of this line gets closer and closer to the slope of this line. I have not used the equal symbol. Okay, so now I'm coming back to our problem. We are given P. What is P?
The 3, negative 40.
Perfect. We are given Q. X, comma,
4 over 2.
right, f of x, right? So I'm given P as being 3 comma negative 4. Of course, 3 and 4, negative 4 are not here. I'm just giving you the idea. So, and I'm given point Q, which has coordinates x, f of x. Agreed so far? So with these 2 points and the given function, I can determine the slope of the secant line PQ. And if you remember, we talked about this during the skills assessment, and we said this is exactly the average rate of change of this function between P and Q. We remember that? It's the slope of the line connecting P and Q. So it is the slope of the tangent line, the slope of the secant line PQ, and which is the same thing with the average rate of change of this function between P and Q. Agreed? Good. So now I would like you to dictate this for the given scenario. Now we plug in what we have. Ready? So I still want to find the slope of the secant line PQ. Please dictate.
Shot in the dark, 4 over.
That is
2 minus x minus
that is
negative
common
4.
sense. That is common sense. So it is 4 over 2 minus x.
Minus negative 4.
Excellent. Which makes it positive 4. Excellent.
This is x minus 3.
Exactly. Exactly. So this is indeed the slope of the secant line between P and Q. And ultimately, we want to determine the slope of the tangent line at P if we can. Or if you want to say approximate, or if you want to say guess, or if you want to say estimate. Because we only have 1 point, we cannot really tell what it is. Okay, what do you think we should do with this?
Try and get rid of the fraction.
Right, this is a complex rational expression. Complex rational expression. We have to simplify it fully. Excellent. Good. So let's do that. The denominator is just x minus 3. There is nothing I can do to it. But what about the numerator? I will tell you one thing that I don't like about the numerator is the fact that it has a twisted binomial here. I don't like this 2 minus x. I'm going to flip it and, put it in the correct order, in descending order. I'm going to write negative x plus 2 and I will factor out negative 1. But I don't like the way it looks. So I'm going to write this. The idea is that in general, not 100%. But in general, we always prefer polynomials to be in descending order. And furthermore, we don't want polynomials to have negative leading coefficients. So when you rewrite it as negative x plus 2, you will factor out negative 1. Positive 4 over negative 1 is negative in front. Is this okay? Any questions? Is this okay? Don't be shy. Please say if you don't understand what I'm doing. It's okay if you say repeat or show more steps or whatever you want to say. Is this okay? Show more steps? Are we okay? Brady? Yes? Okay, perfect. So now the next step would be to find the least common denominator, which is, yes, there is no other denominator. This is over 1. Imaginary if you want. Imaginary 1. And since the least common denominator is x minus 2, there is nothing I can do to the top of the first function that I need to do. It's the same denominator, so the top is negative 4. However, the denominator of this fraction was multiplied by x minus 2. Therefore, I have to multiply the numerator by the same quantity, which is? Excellent. So now please dictate the top of this fraction. So it's negative 4 plus what?
4x minus 8.
Excellent. Great job. Indeed, plus 4x minus 8. Good. I combine like terms at the top. Can anyone dictate the simplified form of this fraction? Of course, it's over x minus 2. Notice that I already will flip the denominator. So I have a fraction at the top and a fraction in the denominator. I will change the division into a product. And of course, that's not what I am trying to do. I'm trying to write 1. Oh, yeah, actually, yeah. Of course. I talk too much. And when I talk too much, that's what happens. So it was x minus 3 over 1. So I have to multiply by 1 over x minus 3. And please give me the top of the first fraction, the top fraction.
4x minus 12.
Indeed. Good. Now I notice something. This is nice and clean. This is nice and clean, but this isn't. What should I do to that expression? What? Excellent.
You can check out 4.
Excellent. What is left in parentheses?
X minus 2.
And now look carefully. Excellent. Thank you. So now we'll look carefully and say, I know what you're going to do next. And I promise to do it.
We cross out the x minus 2.
Please write 1 unless you will never get confused. If you'll never get confused, I'm fine. But other than that, otherwise, you may get confused and say 0 or something, and we don't want that. So put x minus 3 divided by x minus 3 is 1, x minus 3 divided by x minus 3 is 1. And the simplified form of the slope of the secant line is
4 over x minus 2.
4 over x minus 2. So the slope of the secant line PQ is 4 over x minus 2. I'm going to copy here the coordinates of point P, 3, negative 4. And maybe you would like to read our question one more time, Mason. We were asked to find the slope of the secant line PQ.
Yeah.
And then?
Wait for part B.
Yes.
Oh, okay. Using the results of part A, guess the value of the slope m of the tangent line to the curve at P3 negative 4.
Perfect. What do you think we're going to do now?
Now we're going to do y2 minus y1.
Careful. So I have those 2 points, P and Q. I determine the slope of this line.
Or is it y minus y1?
You start plugging in numbers near, I can't remember which one it was, 3 or was it?
That's why I wrote P there, so we don't have to go back to the previous page. That's why I copied P right there.
Wait, now we're using the, like, f of x plus h.
No, it's because the first thing you did is the closer you get to P, the closer you get to the tangent line. Because the slope will be,
At this point in time, all we have to do is plug in.
just plug in 3 up.
I got you.
So the slope of the tangent line at P is
4.
exactly. However, Omari has a point and Mason has a point, and I like to do that. So let's go to the graphing calculator. But I have to do this, I have no choice. Okay, so to the graphing calculator, and let's put in y equals the slope of the secant line PQ without simplifying anything. But you have to be very careful how you put it in. Why do I have to be very careful how I put it in? And of course, I turned this off already. I put it on. So you have to put parentheses around the numerator and parentheses around the denominator when you're plugging in the calculator. So parentheses around the numerator, parentheses around the denominator. So be very careful. So in y equals parentheses 4 over, in parentheses, 3, it was 2 minus x, yes.
Yeah.
2 minus x, close the parenthesis, and then minus 4, so it's positive 4. Close the parenthesis. So we have parentheses around the numerator. We have 4 over x minus 2 plus 4 outside of the fraction. Close the parenthesis for the numerator. And now we divide. And in parentheses, x minus 3. So let's say we have no idea that this simplifies to 4 over x minus 2. We don't. We haven't performed any calculations. Let's assume that. So this is the secant line. So I would like to get closer and closer to x equals 3 and see what the slope of the secant line will give us. So with second and table, I have to do one thing, sorry. So make sure that your table set is in the ask mode. Go back, because otherwise you will not be able to put in the numbers you want. And now finally go to second and table, and I want to evaluate the function that we created, which is the slope of the secant line. That's what we plugged in. I want to evaluate that slope. If I put in 3, I'm in trouble. I can't put in 3. How come?
Because it's not actually on 3, it's like super close.
No. It has x minus 3 in the denominator. How can I put 3 in it and get a number? We did not plug in 3 in the original expression. We worked on it, and we worked on it, and we simplified it, and then now 3 goes in, no problem.
That makes sense, okay.
But if I plug in 3 from the very beginning, I will never get anything.
Okay.
But I can, and this is the concept that we are going to look at right now. But what I have to do is get closer and closer to 3 from either side. It doesn't matter which side. Let's do it both, from both sides. Okay. So let's see what happens at 2. Let's see what happens at 4. Okay, there is also an x minus 2 in there. That's why it didn't allow us. Let's say now 2.5. Let's say 3.5. But these are extremely far from 3. 2.5 is very far from 3. And 3.5 is very far from 3. So now let's see what happens if I put 3.1. Ah, what if I put 3.01? Ah, what if I put 3.00001? Just give me the 4. Because now I'm so close to 3 that you cannot even see it. I'm that close. So I brought Q so close to P that now really this line is the tangent. And the slope is 4. So I went from numbers that are close to 3 from the right-hand side of 3, meaning with numbers larger than 3. Now I want to do it from the other side. Let's say with 2.9. Okay. Let's say with 2.99. Let's say, forget it. Let's say this. Give me the 4. But initially I couldn't put it in. Is that clear? Because we had that x minus 3 in the denominator. But once we cleaned it up, we were able to put in 3. So this is the numerical approach. And what we did was the algebraic approach. We simplified it. And at the end we said, okay, now I can plug in 3. Please.
So would we be able to plug in the calculator, the simplified version, and get the same?
You cannot simplify with a calculator.
Well, no, like what we ended up with here, like the 4 over.
Oh, so you want to plug this in the simplified form?
So like if,
It's going to be the same thing.
okay, yeah.
It's not going to have any problem because it's not undefined at 3. You don't have to, very good question actually. In the simplified form, you don't have to go from left and right to see what you get because you can plug in 3 with no problem.
Okay.
But in the original slope of the secant line, you can't plug in 3 because it had an x minus 3 in the denominator.
Okay.
And as one of my, I observed a colleague of mine, I have to write a report about her presentation. And whenever she encountered division by 0, she said, I really like that, this breaks math. That's all she said, not division by 0, not undefined, no, this will break math. That's what she said. I really like that. Okay, any questions? Very good problem. Any questions? Okay, is there anything else that you worked on? Omari, anything? You want to show me anything? Or I start my, do you have anything for me?
No, not right now.
Okay. Good, so this was a problem that I had in mind anyway, but there is another problem that I have in mind to work with you. A problem, this will drive me crazy. I would like you to choose. So we have several situations here. I know it's not clear. Okay, so we have, this was a perfect example for a perfect question. It saved me a lot of time. I was going to do something similar. So this is problem 3, and I would like you to do problem 3. Maybe at the end of the day today, or maybe even now, if you'd like. I have no problem. We can work on number 3. It's identical with what we just looked at. 2, -1 lies on the curve this. If Q is this point, exactly the same thing. Use your calculator to find the slope of the secant line PQ, correct to 6 decimal places, and it gives us how close we should be to, of course, to 2. We are trying to determine the slope of the tangent line at 2, of course. Using the results, exactly what you said, find the tangent line. Using the slope of part B, find the equation of the tangent line to the curve at this point. So this is one option, and we can start working on it quickly. So to enforce what we just looked at. The second option is problem 6. And the third option is problem 8. So I want you to choose. If not, I will choose. If it takes you 5 minutes to choose, then I'll choose. You lose your privilege of choosing. So we want to look at 3? Okay, 3 is identical. These are slightly different than number 3.
You said A, no, no.
So we can work on number 3 on our own, and then I'll see what you come up with. Is that okay? Okay, so let's do that quickly, and then we'll choose one from 6 or 8. Okay, let's do that. This is not the best setup here at all. Okay, so here is a function. So this is p 2 comma negative 1, and then y equals 1 over 1 minus x. And they want us, they're giving us some values of x. I'm going to put them in the correct order. So obviously they are left and right of 2. So 2 will be in the middle, 2.01 to the right, 2.01 to further right, further right, further right. 1.5 left, 1.9 closer to 2, 1.99 closer to 2, 1.999 closer to 2. So in a table, so this is x, and this is the slope of the secant line, PQ. We have the point Q, which is x, comma, 1 over 1 minus x. And we start in the correct order. Please always think in those terms of putting those numbers in the correct order. They're trying to trick us, of course. And to the right, I have 2.01, 2.01, 2.1, and 2.5. You will always know that I always run out of room, as I mentioned, always, in the case. So determine the slope, simplify it if you want, or not simplify it first, or not simplify it at all. It's up to you. So, and determine and give me, I don't need 6 decimal places, let's say 3 decimal places would be enough. What are we going to write first? The
Slope
of the,
of the secant line.
excellent, PQ. Yes, let's write the slope of this, of the secant line PQ. How are we doing? So also copy Q, so you have Q. So also you have Q, perfect. So let's write the slope of the secant line PQ. Slope of the secant line PQ, MPQ or MSec PQ is, can anyone dictate the slope of the secant line PQ?
1 over 1
It
minus
has to
x.
be a fraction line. So where the equal symbol is, I have to have a long fraction line, and all this is about the fraction line. This is what my grandma used to do, now I'm doing it to you. I'm your grandma. At the top, 1 over 1 minus x. Perfect. Just, I want to see the equal symbol in the same, on the same horizontal line with the equal symbol with the fraction line. If you put the equal symbol here, then you're not considering that this is the middle of the problem.
So what did you say?
So yes, so we have to erase it from here and put it here. That's where the equal symbol has to be.
Mhm.
And this is still that. Perfect. Excellent. So now try to simplify it if you want, or put it in the graphing calculator as is, and plug in the numbers we see up here. So now, first of all, what are we trying to do? What are we trying to determine? Why am I ever interested in determining the slope of the tangent line of P? What does that give us? Yes, what does it give? Why am I interested all of a sudden in the slope of a tangent line? Anyone can clarify that?
Oh, because it gives us the,
Rate of change, the instantaneous rate of change at that point. So when I drive somewhere and you call me and you say, you're driving, yes, I'm driving, and you say, look at your odometer, what is your speed? I'm gonna say 45 miles an hour. That's the instantaneous rate of change. So at that point, on that graph, at that point, the function changes at that rate, whatever we find. Like in the previous problem, it changes it with 4 whatever miles an hour, or grams per liter, or percentage of concentration per hour, or that's why we want to determine the rate of change at a particular point, the instantaneous rate of change. Okay, so are you ready to give me any of these numbers? Can anyone give me any number? What did we get with 1.5? What did we get with 1.9? What did we get with anything?
I think I got that equation.
Yeah, I think I messed up simplifying, but I'm trying to get it calculated. I had the raw equation, I was trying to simplify, may have messed up somewhere there.
You're way ahead of everyone, but I still want a number for 1.5.
2?
Maybe I made an error, so I shouldn't say anything. Did you put enough parentheses? Were you, so let me see the function. So we had x minus 2 and x minus 1, 1 over x minus 1. Did you put x minus 1 or x? You put 1 minus x. You put 1 minus x instead of x minus 1. Oh, no! Don't change it. I made an error. I put x minus 1. It's not you. I'm pretty sure I made an error. Yeah. Don't change anything? Vicky, sorry, thank you.
Nope.
Okay. Yes, I did get 2. Thank you. Thank you. I did get 1.111. I did, and that's next one, 1.0101. And 1.001. Am I correct? Has anyone checked? Now I'm going the other way. Does anyone have any number for me?
For 2, I have 1. Well, it might not be correct, I think I put in.
I'm sure you're correct. I'm sure, but I still have to fill in the other ones. So I got this, I got 0.9901, I got 0.9090, and I got 0.6667.
When I put in 2, I got error.
Of course, because the denominator is x minus 2. But now what I would like you to do is plug in 2.000000001 and see what you get. Of course you will get 1. Look what happens. On the left-hand side I have 1.01. On the right-hand side I have 0.99. Where are they going? towards what? The left-hand side is 1.001. The right-hand side is 0.999. Where are they going? Exactly. No doubt. No doubt that your guess is good. Although you cannot plug in 2 because the denominator is 0. Very good. And then we're asked to determine the slope. We did. And then we're asked to find the equation of the line, which we reviewed last time or last week. We have a point, 2 comma negative 1. We have the slope, which is 1. So then y minus y1 equals the slope times x minus x1. Agreed? So this is your 2, this is your negative 1, and this is your 1. Is that okay? So the equation of this, the tangent line to the graph of the function at P is y equals x minus 3. We have to solve for y. It has to be in the point slope form. Of course, in the slope intercept form, I meant. Okay. So are we in the clear with this first section? What we're asked to find? The target is the instantaneous velocity or instantaneous rate of change or the slope of the tangent line. They're all the same. But I can't determine the slope of a line having only one point. I have to start with a secant. Now then I'm going to say, okay, if I move the 1 point closer and closer, closer and closer, do I get the tangent? I do. That's what we did. We got closer and closer from either side to this point because we could not plug in 2. Is this better?
Yeah.
Yes? Okay. So if you'd like to choose another, we can. If not, we'll move on. It's up to you.
Can we do number 8?
Let's do number 8. It says it's a displacement in centimeters of a particle moving back and forth along a straight line is given by, okay. So this is problem 8 on page 86. This one was 3 on page 86, my apologies. I always write, I don't know why this time I didn't. So 8 on page 86, and we are given the function s equals 2 sine pi t plus 3 cosine pi t, where t is measured in seconds, and the displacement, or s, in centimeters. Find the average velocity during each time period. They are given us 4. So here's number 1, 1 comma 2. Here's number 2, 1 comma 1.1. Here's number 3, 1 comma 1.01. Here's number 4, 1 comma 1.001. So they're asking us to determine the average rate of change for this function between the given points. So for the first one, the average rate will be, I'm going to write as s of t, they should have, and it should be s of t. They just write s, but it's a function of t, s of t. Can anyone dictate? Just the first one. We have a function, and we want to determine the average rate of change between 2 points. One point that has x or t equals 1, and the other point that has t equals 2.
So basically the same as the last problem, if I'm reading it right. So it'll be, do I have to read all that off at once?
Just the first one.
Sine.
No. Just use s of t.
Okay, s of t.
S of,
Wait,
Oh, no, sorry, I said 2.
s of 2 minus, yes, over,
2.
that's it. And of course, I will repeat the same procedure, right?
That's not one.
We're talking about this. We're talking about this. X with 1, X with 1, and X with 2. X is 1, this is f of 1.
I thought that number
They're
one
brackets.
was a point.
They're
not an
brackets.
interval.
They're
Okay.
brackets. Closed interval. Yes.
I thought it
So
was
this is
a
1 and this
point.
is 2. This is f of 1 and this is f of 2.
Okay.
Is that clear, everyone? Okay, perfect. So is the average rate formula clear? S of 2 minus S of 1 over S2 minus x1. Over, in this case, 2 minus 1, but it's x2 minus x1. Very good. Or t2 minus t1. I don't want to repeat this. You can. It's nothing wrong. I just want to show you a different way of determining these numbers. So in general, what changes here? Not 1. 1 does not change, it's the same. So this doesn't change, and this doesn't change. What changes is 2, 1.1, 1.01, and 1.001, correct? This changes, and this changes. This is fixed, this is fixed. For all 4 situations, S of 1 is S of 1. Would you agree?
Yes.
Okay. The other thing before we start, make sure that your calculators are in the radian mode. Okay? I'm going to show you in a moment, but I just want to show the function first because once I switch to the computer, it will take me 5 minutes till I recover when I want to go back. So I want to just create the function. So we're going to create a function instead of, you don't have to. You can determine 4 numbers, 1, 2, 3, 4, by just plugging in. I want to show you a different way. I will create a function that has s of t minus s of 1 over t minus 1. Once I plug this function in, I will plug in for t what?
2.
And then I will plug in for t. Exactly. Then I will plug in for t. And I will plug in finally 1.001. And I will get all numbers at once instead of calculating or redoing this 4 times. You don't have to. So let's plug it in. So first of all, s of t is s of t, and I plug in s of 1. And then I don't have t in the calculator, so it's going to be x, but that's okay, same thing. And then denominator x minus 1. Ready? Because once I switch, okay, so here it is. Let's go back to y equals. Make sure that the mode is in radian mode. It is. I go back to y equals. I clear what I have. I put parentheses around the top, of course. It's a rational function. And I copy s of t to sine pi. Pi is right here with a caret. T, I don't have t, I have to use x. Close the parenthesis, plus 3 cosine, in parentheses pi, x, close the parenthesis. Now remember we have to subtract s of 1, so we subtract 2 terms. So minus, let's think for a moment. When I replace, look at the function for a second. When I replace 1 in sine, and I get sine pi, what number do I get for sine pi? Remember, sine is measured on the y-axis. What are the values of sine at 0 and pi?
0.
0. So I don't even have to put in the first function, the first piece of the function. Agreed? So I only have to write actually minus 3, because when I plug in cosine, right? When I plug in cosine 1, I get cosine pi. How much is cosine pi? Negative 1. Times 3 is negative 3. But I have a minus, right? I have a minus in front of the second term. So it's going to be plus 3. That's it. Close the parenthesis for the top. And finally, I divide in parentheses by x minus 1. Let me know if you fell behind, or if you need my help, if you need me to come over. Is this okay? So we evaluated S of 1 to be actually -3. So now with second and table, I plug in all these numbers. 2, and then 1.1, and then 1.01, and finally 1.001. This is simply an elegant way of solving this and answering. So I'm going to write these numbers. So the first one is 6 centimeters per second. The second one is -4.7 centimeters per second, which only means the direction of the particle. It does not mean that the speed is -4.7. It just tells us that if it goes in this direction, this speed will be positive. If it comes back, the speed is negative. That's all it means. And then -6.134. And then the last one, -6.268. And I'm sure you are wondering, because the problem has to ask us, what is the slope of the tangent line at 1? Okay. So for that, I'm going to do this. Just give me the number. Too close. It was too close. So then, because we know we cannot plug in 1. So what is the instantaneous velocity of this particle when time is 1 second?
So it would be -6.
-6.283, which means it's coming back. That's all it means. So the instantaneous velocity at t equals 1 second is -6.283 centimeters per second.